This is part 2 of the lecture over your assignment number 8. In part 1, we went over the exponent rules, when to add, when to multiply, and when to subtract exponents. We learned about negative exponents, and if you raise something to a 0 power, it always becomes a 1. So those were those 5 rules that you learned. In part 2, we're going to be adding and subtracting polynomials. One thing I want you to understand is we're thinking a lot about like terms in this assignment. Okay, when we're adding and subtracting polynomials, something to be aware of, some terminology. A polynomial is just a variable expression in which terms are monomials. For instance, this is a monomial. A monomial. Each one of these are just considered terms. Okay, but if the polynomial only has one term, like let's say 2xy, that's one single term. They're not being separated by a plus or minus sign. That's called a monomial. A binomial would have two terms. So maybe something like 2xy plus 3. And a trinomial might have 3. So maybe something like x squared plus 2xy plus 3. Notice that each term is being separated by a plus sign, or there could be a minus sign, but each one of those is just called a term, and we're counting them. If you have a term that has more than 3 terms, or a polynomial, excuse me, that has more than 3 terms, then we would just call that a polynomial. To find the degree of a polynomial, it's just whatever the greatest of the degree in any of its terms. We'll talk about that a little bit, but like looking at this, the largest exponent is a 3, so this would be said to be in the third degree. One thing that we'll be doing is writing things in descending order. So you look at the biggest and then you write them in descending order, like 3, 2, there's an understood 1 exponent for x, and then your constant is always last because it doesn't have a variable. It would be like no degree. There's no variable being raised to a power when there's just a constant. Your leading coefficient is the number part, the coefficient of the variable with the largest exponent, so the number part of the one with the largest exponent. So in this case, it'd be like -5. And again, I already said this, the term without a variable is called your constant. So if we were answering these 3 questions, the first thing you would just do is put it in descending order first. So remember, that's not just like saying minus 5x cubed. That's like a negative 5x cubed. So we need to keep that negative sign with it. And then we have a negative 4x squared. We have a positive 7x and a positive 9. So if you don't see a sign in front of that first term, it's positive, so you would put a plus sign. So we want to first write it in descending order to help us answer this. So the degree of the polynomial should be the first term's exponent if you have it in descending order. So this would be the third degree. The leading coefficient is the number part of that term. So it's just a -5. And the constant term in this problem is a 9. Mostly what we're doing is putting things in descending order. We don't often have to talk about the degree of the polynomial, but we do refer to that a little bit later. But again, it's really just the largest exponent of that problem. If you're evaluating a polynomial function, you're just replacing each variable with whatever the assigned value is, and then calculate it. Do your order of operations, okay? So if this says evaluate p of x, and then this is the polynomial, when p, and then in parentheses, you see a -5. That's just a fancy way of saying x equals the -5. You're going to plug that in for the x, or whatever the variable is in the problem, and simplify. So let's do that. We have 2 times a -5 minus 4 times a -5 squared. So be careful of that, plus 5. You could type this into your calculator and make your calculator calculate that. 2 times a -5 minus 4 times a -5 squared plus 5, that would be fine. giving you a negative 105. If you're not using your calculator, hopefully you remember PEMDAS, which there's not anything inside of a parentheses to simplify. That's just a number, but we do have exponents, so you would need to do that first. So 2 times a negative 5 minus 4 times negative 5 times negative 5 is 25. And then we could simplify this. So 2 times a negative 5 is a negative 10. Negative 4 times 25 is a negative 100, and then plus 5. And then if you took negative 10 plus 100, you would get a negative 110, plus 5 would be your negative 105. So it's good to know how to do that without your calculator. However, I know we have that tool, so just make sure when you enter it correctly and you practice that. It looks a little bit like my printer cut off part of this problem. So we're going to change this problem just for purposes of lecture today, where it's just these two, which is still okay. So when we're adding polynomials, basically we're just combining like terms. We're going to ignore the parentheses, write the like terms next to each other, whether that's side by side or vertically. You're going to see in WebAssign that it'll tell you to do one or the other. I don't care which one you do. I will do both today in the notes. But one thing you need to do when you're combining like terms, you need to remember that they have to have the same exact variable parts with the same degree to be like terms. So that's just a review of what a like term is. When we're adding polynomials, we're not changing the exponents like we did in the part 1 video. The part 1 video was you were multiplying terms together, which made you add those exponents. But here we're combining like terms. I like to think of, sorting laundry. Instead of seeing a squared twice, we're combining the numbers in front, and we only see a squared one time in our answer. So if we were going to do this one horizontally, I have an a squared term here and an a squared term here. So I'm just going to write them side by side. It's just a nice way to collect your information, be organized. And then I have an a term here and a negative 2a here. And then we have constants of negative 10 and positive 7. So all I've really done is just write them side by side so I can see them easier. So 6 minus 3 is just a positive 3a squared. 8 minus 2 is a positive 6a, and a negative 10 plus 7 is a negative 3. And so we only see each variable one time, the a squared, the a, and the constant one time. So we have combined like terms. There's nothing else you can do to that. If we were doing this one vertically, remember I deleted part of that problem, which is fine. It's still the same type of concept. So I'm going to write this one vertically this time, and I usually always do try to make sure I keep it in descending order as I do. So if I have a 4x squared, that means over here, this is the x squared term. So it's not always in order. You're not just adding the terms in order. You're looking to see that they're like terms. It just happened to be that these two were already in descending order and in the same order of a squared, a, and constant. This one's kind of all jumbled up, so we have to collect their like terms. So I'm going to write negative 2x squared here. We have a positive 5x right here, and over here we have a positive x. And then we have a minus 3 and a plus 7. So all I've done is just rearrange it so that like terms were on top of each other. So again, since these are x squareds, all I'm doing is looking at the coefficients, the number in front. 4 minus 2 is a positive 2x squared. Remember that there's an understood 1 in front of our x's. We need to remember that because you are adding 5 plus 1. So a positive 6x, and a negative 3 plus 7 is a positive 4. And that is as far as we can go with that. Because again, these are not like terms now. We've simplified them to see the x squared term by itself, the x term, and the constant by itself. When we're subtracting polynomials, it's really very similar to what you just did, except for you have one extra step. Anytime you have a negative sign in front of a parentheses, basically what's happening is it goes to every term inside. So anytime there's a negative sign out in front, you must distribute the negative to each term within that parentheses. That means those signs will become just the opposite. So we're going to change this to a plus sign. But if I were thinking of it, it would be like saying a negative times a positive made that a negative 2x cubed. I had to put it above. So that's showing that that's negative. A negative times a negative would have made that a positive. When this was a negative sign times a positive, that would have made that a negative. So we just changed the signs to the opposite. We always make this a plus sign because we have distributed it, making that like it's a negative. So now we can just combine like terms like we did before. Again, you can do it vertically, you can do it horizontally, it doesn't matter to me. So I have a negative 2x cubed here. I'm going to put it under that x cubed. This polynomial doesn't have an x squared. So I'm not going to write anything under there, but it does have a positive x. I'm just going to make a little gap because I'm doing this one vertically. And then we have a minus 4 right there. So negative 2x cubed and negative 2, those are same signs, so we add them. So negative 4x cubed. I'm not adding anything to the x squared. I'm remembering there's an understood 1 in front of that x term. So negative 4 plus 1 is a negative 3x, and 1 minus 4 is negative 3. So the only difference between subtracting the polynomials, it's like saying I'm taking this polynomial minus this one, is I change the sign and then I just ignore the parentheses and combine like terms. So one more example for this. So again, because there's a minus sign, we need to change all these signs to the opposite of what they were. So I just show that in red so you can see the sign change. And then you can write this in vertical or horizontal form, however you like to collect your like terms. So I have an x squared term and a positive 4x squared term here that I'm writing side by side. I see that I have a negative 7xy and a positive 7xy that I'm going to write side by side. I have a positive y squared and a positive 3y squared. And then finally, on my constants, I have a positive 5 and a negative, because we changed that sign, so a negative 2. So when we go combine like terms now, we can do that. We can see it a little bit clearer. Some students don't like to rearrange it. I think it's always a good idea, especially if you have a lot going on. But I know that you may be capable of saying 3 plus 4 is 7x squared without rearranging it, but it's a good habit to be in. If we had negative 7 and positive 7, that's going to zero out. We would not write like a 0xy. Okay, we're just not going to have an xy term now. Again, remembering that there's an understood 1 in front of your y squared. Since there's not, you don't see a coefficient, there's an understood 1. So 1 plus 3 is a positive 4y squared. And 5 minus 2 is a positive 3. So we have combined like terms. And some students would ask, is that in descending order? I haven't really talked about that on the other ones because they all were, we put them in. And this would be considered in descending order. I know they're both x squared and y squared. They're both squared. But if we think about putting things in descending order, oftentimes we also think about alphabetical order. So you would put this term in front of that one. Is it completely necessary? What if you would have wrote those y squareds first? That would be fine. I don't know why you would, since we were working left to right anyways, but I'm not going to count that wrong. But as you work with descending order, you're going to notice that we go by, big to small, descending, and also sometimes alphabetical.